Every time you tap a website, send a message, or play a video, something extraordinary happens. In less than a second, your request travels across cities, countries, and even oceans before returning with exactly what you asked for. It feels almost magical. But here's the mystery. There isn't one giant computer called the internet. There isn't a central control room directing billions of connections. So how does information consistently find its destination in a network so massive that it spans nearly every corner of the planet? The internet is best understood as a gigantic network of networks. Millions of smaller networks, belonging to homes, businesses, schools, governments, and companies, are all linked together using shared rules for exchanging information. Think of it like the world's largest transportation system. Instead of roads carrying cars, the internet carries digital information. Every connected device, from smartphones to smart refrigerators, becomes another stop on this enormous map. But simply owning a phone or computer doesn't automatically place you on this network. Your device first needs a connection. At home, that's usually your Wi-Fi router. Your phone or laptop communicates wirelessly with the router, which acts like a bridge between your local devices and your internet service provider, or ISP. Your ISP owns the infrastructure that connects neighborhoods, cities, and eventually the wider internet. Without an ISP, your devices could talk to each other inside your home, but they couldn't reach the rest of the world. As soon as your device joins the internet, it receives something essential, an IP address. You can think of an IP address as a digital home address. Just as a postal service needs an address to deliver a package, the internet needs an IP address to deliver information to the correct device. Every device connected to the internet uses an IP address so other computers know exactly where to send data. Of course, nobody wants to memorize strings of numbers every time they visit a website. That's where the domain name system, or DNS, comes in. DNS works much like the contact list in your phone. You remember a person's name instead of their phone number, and your phone looks up the correct number automatically. When you type a website name into your browser, DNS quickly translates that familiar name into the website's numerical IP address. This entire process usually takes only a fraction of a second, making the internet feel effortless even though several important steps happen behind the scenes. Now your browser knows where to send its request. But instead of transmitting one enormous block of information, the data is divided into tiny pieces called packets. Imagine shipping a huge puzzle by placing its pieces into many small boxes instead of trying to move the entire puzzle at once. Each packet contains part of the information along with instructions about where it's going and how it fits back together when it arrives. Breaking data into packets makes the network more efficient because different packets can travel independently and even take different routes if necessary. Those routes are chosen by specialized devices called routers. Routers act like highly intelligent traffic managers. Whenever a packet reaches one, the router examines its destination and decides which path is currently the most efficient. If one route becomes congested or unavailable, packets can simply be redirected through another route. The remarkable part is that no single router knows the entire internet. Each one only makes the best decision based on the information available at that moment. Yet together, billions of these decisions guide information across the globe in seconds. Many people imagine satellites carrying most internet traffic through space, but reality is far more surprising. Although satellites play important roles in remote areas and specialized communication, the overwhelming majority of international internet traffic travels through fiber optic cables lying on the ocean floor. These cables are thinner than many garden hoses but stretch for thousands of miles between continents. Inside them, pulses of light race through incredibly pure glass fibers, carrying enormous amounts of information at astonishing speeds. Under the oceans, a hidden web of cables quietly connects much of modern civilization. Eventually, your packets arrive at their destination, a server. A server is simply a computer designed to provide information to other computers whenever it's requested. Many servers live inside enormous data centers filled with thousands of machines operating around the clock. When you visit a website, request a photo, or search for information, servers retrieve the correct data, divide it into packets, and send everything back across the internet to your device, where the packets are reassembled into the page you see on your screen. This entire chain of events happens every time you press enter after typing a web address. Your browser asks DNS for the website's IP address, sends packets through your ISP, routers guide those packets across countless networks, the server prepares the requested information, and the response races back along the fastest available paths. All of this usually happens so quickly that it feels instantaneous. Streaming platforms like YouTube make the process even more impressive. Instead of waiting for an entire video to download, your device receives small chunks continuously. As you're watching one section, the next sections are already arriving in the background. Popular videos are also stored on servers located much closer to viewers through systems called content delivery networks, reducing travel distance and helping videos begin playing almost immediately. Whenever you notice the small padlock beside a website address, you're seeing HTTPS at work. The S stands for secure. HTTPS encrypts the information traveling between your device and the website, transforming readable data into coded information that appears meaningless to anyone who intercepts it. Only your device and the intended server possess the keys needed to unlock the original message. It's similar to mailing a locked box instead of an open envelope. Despite its importance, several myths about the internet persist. It isn't floating in the clouds. The cloud still depends on physical computers, buildings, cables, and electricity. Satellites aren't responsible for most online communication. And the internet isn't a single machine owned by one organization. It's a global collaboration built from countless independent networks following common technical standards. Perhaps that's the most astonishing part. The internet isn't remarkable because it's invisible. It's remarkable because billions of independent devices, companies, and networks cooperate without anyone controlling every connection. Every search, every message, every video, and every online conversation depends on countless systems working together with extraordinary precision. The next time a web page appears almost instantly, remember that behind that simple click lies one of humanity's greatest engineering achievements. A worldwide network that transforms flashes of light, mathematical rules, and billions of coordinated decisions into the digital world we now take for granted.